As a layman, I would now say, I think we have it. You agree? Yeah. Okay.
While scientists at CERN were catching a glimpse of the first few moments after the Big Bang, people in India awoke to the realization that there was a Bose in boson.
But what about the other scientists who put the Bose into boson? Satyendra Bose came from Calcutta. He too laid the groundwork several decades ago for what's now being called the greatest scientific discovery of this generation. And there's some anger in India at the lack of recognition given to Bose, one of their own. India's government calls him a forgotten hero.
In 1924, a young and completely unknown Indian scientist sent Albert Einstein a letter, and the resulting publication would change physics and Indian science forever.
3 great shots in the dark had already been fired. One was, of course, Planck, who came up with the very basic idea of the quantum. Einstein, with his theory that light consists of a stream of photons, and somehow they also travel like waves. And Neils Bohr in 1913. So these 3 great shots in the dark had already been made when Bose entered to fire the final and 4th great shot in the dark.
Bose's passion is how do we count all the particles, all the photon, everything in the world. Fact that his name is associated on 1/2 of the particles in the whole world. We are all proud as Indians.
At the same time as Bose was counting photons, 2 other young Indian scientists were busy revolutionizing physics with their very own theories. C.V. Raman gave the world the Raman effect and redefined how we see light and color. Meghnad Saha produced an equation that explains stellar radiation and is considered one of the fathers of modern astrophysics.
Meghnad Saha, C.V. Raman, Satyendra Bose were the character who wanted to do first time in India and which is first time also in the world. That was their passion.
All 3 scientists started their illustrious careers at Calcutta University in 1917. All became Fellows of the Royal Society, and one of them, Raman, was awarded India's first and only Nobel Prize for Science.
He cried on the stage. He said, "My poor country does not have a flag of our own, so I cannot claim that I have come here as an Indian."
But who were these remarkable men? How did they overcome colonialism, British rule, racism, inadequate funding and limited resources to place India at the cutting edge of world science more than 20 years before independence? What is the legacy they left behind? And what can India learn from them to produce great science once again? This is their story. Bose, Raman and Saha, the Quantum Indians. In 1917, a new spirit was blowing through the streets of Calcutta. The grand capital of British India and the jewel of the empire was stirring with revolutionary activity. The partition of Bengal in 1905 had reinitiated a movement to free India. At Calcutta University, a very different revolution was underway. A revolution in science. Indian science had a long and rich history. India had given the world the zero, Sanskrit, yoga, Ayurveda, and 2 of the world's first universities at Nalanda and Taxila. But then, from the 11th century, India entered a dark age with the destruction of great learning centers by invaders. By the time the British colonized India, it had lost much of her once cherished scientific vigor. Then, from the 19th century, a new age of enlightenment began, and Calcutta was the epicenter. This was the Bengal Renaissance.
Raja Ram Mohan Rai is the pioneer of Indian Renaissance. It is Raja Ram Mohan who first wrote to British government in 1823 December that India needs a science institution.
Roy founded Hindu College in 1817, educating Indians in English for the first time. This was later renamed Presidency College by Thomas Babington Macaulay. Then, Lord Canning established the University of Calcutta in 1857 to educate citizens of the empire from Lahore to Rangoon. When Ashutosh Mukherjee became Vice-Chancellor in 1906, he began working on Roy's dream of a science college. In 1914, with generous donations from Sir Taraknath Palit and Sir Rash Behari Ghosh, he launched the University College of Science and Technology. Meanwhile, at Presidency College, two young MSc students were making waves. Satyendra Nath Bose and Meghnad Saha had stood jointly first in their MSc examinations and were ready to take on the world. Around the corner, at the Indian Association for the Cultivation of Science, another young scientist, C.V. Raman, was creating a stir with his experiments and papers. Mukherjee realized that in order to make his science college great, he would need people like this. Meanwhile, a very different revolution was taking place in Europe. The old physics of Newton and Maxwell was being turned on its head.
A lot of revolutions were taking place in science, particularly physics. And the old world of classical physics was kind of breaking down.
The first revolution was in the atom. The Greek philosopher Democritus had first proposed that the universe was made up of atoms in the 5th century BC. Everyone assumed that atoms were solid, indivisible objects. Then, in 1897, J.J. Thomson discovered that the atom was not solid at all, but made up of tiny corpuscles. The billiard ball model of the atom was shattered, and science would never be the same again. The second revolution was in light.
Newton said light consists of particles like bullets, and he constructed a very successful theory. Then somebody discovered wave-like property of light, and that happened in the 19th century. Then the notion of corpuscular theory of light was abandoned.
The third revolution was in radiation. When a hollow black body was heated, it was meant to radiate spectrum at an infinite rate along a straight line. But this did not happen, and a curve resulted that seemed to come back on the spectrum. No one could explain this.
Europe was completely puzzled. And then Planck somehow wrote down a formula which fits this curve exactly and accurately fits all the experimental data. Having written down that formula, he wanted to derive it from some theoretical framework.
Max Planck came to the conclusion that energy was being let out in discrete energy quantities or particles. He called these particles quanta. The equation came to be known as Planck's law. This was the beginning of the quantum age. Then three amazing developments occurred. Einstein demonstrated that light was both a wave and made up of particles he called light quanta. Lord Rutherford discovered the solar system model of the atom, with a dense positive nucleus and electrons spinning around it. And finally, Neils Bohr demonstrated that those electrons could only move at the quantum energy levels predicted by Planck.
So these three great shots in the dark had already been made when Bose entered to fire the final and fourth great shot in the dark.
So this is Bose's home, childhood home. He was born here in 1894. The house hasn't changed very much there. His room was there, and that's where he spent all of his time in his older years. There's stories abound about, during the famines and everything, how he would go out and take his food and away from the table and feed the kids outside. And so that he had a kind of kindness and gentleness throughout his life, and that was his personality. When he was younger, his father used to write sums here on the courtyard. So that's where the first mathematics actually started here on the ground. All my life, I had really heard about Bose and how great famous my Dadu was. My parents always told me, oh, you know, your grandfather worked with Einstein. And I used to go into bookstores and always look for the Einstein section, the biography section. But I used to take down every book of Einstein and flip to the back of the index and look up B. And so there was always Bose. It made me feel good in a way, you know. And you know, in high school they start teaching you physics, and I mentioned to my physics teacher, oh, you know, Bose is my grandson. He goes, oh, you must be a genius. I unfortunately disappointed him.
Satyendra Nath Bose was born in Calcutta in 1894. His childhood was immersed in art, culture, music and education. He demonstrated a flair for mathematics very early on and amazed his teachers with his abilities. In 1914, he married Ushabati, and together they had 9 children.
I was his student. I think I was the last one who did his PhD with him. He was already a grand old man of physics at that time, a national professor. And it was just by chance that I went to see him one day. While we were talking, he suddenly said to me, "Tui amar shonge kaj korbi? You want to work with me?" I couldn't believe what I was hearing. And I became a junior scientist attached to the national professor of physics, S.N. Bose. Oh, he was a towering figure and an icon whose name was associated with Einstein.
When Bose got to Presidency College in 1910, he studied applied mathematics with Saha. Those were heady days, and many young men were drawn to the freedom movement.
P.C. Ray used to meet them at the bottom of the Octonony monument in the evenings, where they would discuss the future of the country. 2 groups were formed. One went into direct action. The other group said, no, we will not go into direct action. When we get independence, who's going to do all the science and technology, and knowledge is essential for progress.
Bose stood first in his BSc, and then he and Saha took a joint first in their MSc examinations. When Mukherjee founded the new University College of Science, Bose and Saha jumped at the chance of teaching there.
So these young guys went and convinced Sir Ashutosh that they were competent to start the physics department.
He said that you set up all the laboratories, libraries, get books, equipments. I will start the classes from 1917. 2 years I am giving you to prepare.
Most of the important papers were being published in German and some in French. So they learned French and German.
The brave new world of theoretical physics was unfolding a whole new universe.
And they were the first people to actually translate Einstein's papers on relativity into English. And it was published by the Calcutta University. So they were making waves, and they were voracious readers and superbly intelligent people.
Ashutosh Mukherjee appointed C.V. Raman as the new Pilot Professor of Physics in 1917. He was an experimentalist and not a theorist like Saha and Bose.
In 1920, Ashutosh made Saha as a professor. So Saha is now a Khoira professor, Raman is already a professor, but S.N. Bose does not have even a readership.
To further his career, Bose moved to East Bengal in 1921 and became reader at the newly founded physics department of Dhaka University. In 1924, while teaching a class on quantum physics, Bose had a eureka moment. Bose had been very dissatisfied with the way Planck's law was being derived in Europe. Earlier, Ludwig Boltzmann had developed a mathematics using probability and statistics to predict how gases worked in a closed thermodynamic system. Bose realized that he could apply statistics in a novel way to predict the number and probability of Einstein's photons using Planck's equation in the same way. A new statistics would be needed that could work at the quantum level to count photons. This was Bose's great breakthrough.
What he showed was that in the case of photons, classical statistics doesn't hold. It's a new statistics, which is now of course called Bose statistics. So there are new kinds of objects which people were not aware of. So the first paper was called Planck's Law and the Light Quantum Hypothesis.
He sent his paper first to the Film Mag in Britain, but it was turned down. And then, in one of those seminal moments in history, he decided to send his paper to Albert Einstein. It was a bold decision and became one of the great moments in modern science. Respected sir, I have ventured to send you the accompanying article for your perusal and opinion. I am anxious to know what you think of it.
So Einstein was delighted. He said, this is what I was looking for. So my photons are not like classical billiard balls. They are bosons. And so overnight, Bose became a very, very famous name in the world of physics.
Einstein then sent a postcard to Bose saying his work was a beautiful step forward. When Einstein's postcard arrived, Bose became an overnight celebrity and was immediately granted permission to travel to Europe to meet Albert Einstein.
So in the first year, he actually spent a lot of time with Maurice de Broglie, who was setting up the X-ray crystallography lab. And then he worked for 6 months with Madame Curie.
He proceeded to Berlin the next year. And in addition to meeting his hero Einstein, he also met some of the leading theoreticians of the age.
Einstein was so impressed, he said, Bose's way of counting should not only apply to photons, it should also apply to material atoms. That was Einstein's extension of Bose's idea. You get a quantum gas of material particles, and finally, that at very, very low temperatures, everything can condense. If all the particles condense into the lowest energy state, then you have a new state of matter, which has now come to be called the Bose-Einstein condensate. Now in 1928, Paul Dirac wrote a very famous book called The Principles of Quantum Mechanics. And in that book, he coins the two words bosons and fermions. So, you can say that half the particles in this universe are bosons. And as somebody said, as long as there is light in this universe, there will be bosons everywhere. It's one simple idea in Dhaka completely revolutionizes everything, and then, of course, Bose becomes a household name, or rather boson.
Bose returned to Calcutta University in 1945. He founded the new organic chemistry labs and also worked on trying to solve the unifying theory of physics that Einstein had been working on.
So Einstein used to call it the unitary field theory. He found it very odd that there were both waves and particles. And he proposed a theory which would do this. But there were various objections, and Einstein started communicating with him again. And Bose wrote this paper and was very eager to go and actually discuss this with Einstein. Einstein passes away before the meeting takes place. And the story is that when this news arrived, he simply tore up that paper and threw it into a waste paper basket. So there is this unfinished symphony hanging there.
Rabindranath Tagore dedicated his seminal work on science to Bose after hearing about him from Einstein. In 1956, Bose became Vice-Chancellor of Tagore's newly created university at Shantiniketan. The vision was to bring about a scientific revolution in Bengal. But Bose faced obstacles from the status quo at every turn, and after 2 years he returned, frustrated, to his home in Calcutta. But things turned around that year, and Bose was finally inducted as a Fellow of the Royal Society. And then, in 1959, in recognition of his achievements, Prime Minister Nehru appointed Bose the first National Professor of Physics. At that time, Bose had started teaching at the Indian Association for the Cultivation of Science, which Raman once had made famous.
When he became national professor, that he would get a fellowship, research grant till end of his life, he did not choose Calcutta University. He thought ISCS is the best place.
People sometimes tell that Bose didn't get Nobel Prize. But how many Nobel Prize winners' name are learned by every physics student?
Bosons are so fundamental, Bose statistics is so fundamental in modern physics that it's one of its cornerstones. The whole edifice would simply collapse without it.
So, what was Bose's great contribution to physics? Well, without Bose's statistics, we would not have been able to count photons and predict their behavior. Nothing we take for granted today, like lasers, fiber optic communications, superconductors, or the future in quantum computing, would have been possible without Bose's counting methods. And without bosons, we would never have understood how matter came into being after the first few moments of the Big Bang, or what makes up most of the universe at the quantum level. He also dedicated himself to making science available to Bengalis in their mother tongue. This became his life's mission.
He said, look, when I talk about learning science through the mother tongue, I am not thinking of people like you who will be actually doing science. For people like you, you will have to learn all the languages that you need to learn. But I'm talking about the average Indian. Does he have to learn a foreign language just to be able to follow the basic things about science? How is that possible?
Bose spent the rest of his life teaching at IACS and his room at home, managing the Science Association of Bengal, meeting people from all walks of life, playing the Esraj and the flute, discussing philosophy, and teaching young minds about the new frontiers of science. Finally, on the 4th of February 1974, Satyendra Nath Bose passed away, and it was said that with his passing, an era ended. An era of great men who created science in India.
After all, if one has lived through so many years of struggle, if at the end he finds that his work has been appreciated, he feels that he doesn't need to live long. তুমি কেমন করে গান করো হে গুণী। See, the real science begins when you are really interested in something and you want to find out.
And he was actually cremated over there. And then the question arose, should there be a monument? People decided, no, this must not happen to Raman. And a fitting tribute to him should be a tree.
To understand C.V. Raman, we have to understand his love for nature and the human spirit. He believed that the human spirit never ceases from questing. Why was the sea blue? Why do flowers have colors? How does the tabla make its sound? Why did crystals refract so much spectrum? Raman was a man of many contradictions. A great teacher, but an intolerant perfectionist. A simple man at heart, but a supreme egotist. A recluse, yet he loved children and teaching. But without doubt, a genius. Chandrasekhar Venkat Raman was born in November 1888 into a conservative Tamil family. He was surrounded by learning and tradition as his father was a lecturer at Presidency College, Madras. He became the youngest student at Presidency College and completed his MA at 18. As a young man, he was influenced by Edwin Arnold's classic book The Light of Asia, as it explored the life of the Buddha, who overcame the problems of his age through intellect and willpower. 1907 was a turning point in Raman's life. He received his MA that year. He was married to his wife and lifelong partner Lokasundari and had 2 sons with her.
And then he sat for the Indian Financial Service exam. There he stood first and he got a job as Assistant Auditor General, Government of India. And this, since Calcutta was the capital, the head office of this Auditor General was in Calcutta. So that is how he came.
One day, while taking a tram to work, he noticed a sign outside the Indian Association for the Cultivation of Science.
And he entered and he found an excellent, outstanding library, very good equipments. And he said, I can start working here immediately.
He loved spending his mornings and evenings at the association. And by 1909, he had published his first paper in Nature magazine on the effects of vibrating strings. When Mukherjee asked him to become the first Pilot Professor of Physics, Raman jumped at it. His experiments and publications at IACS and Calcutta University made him world famous. On a trip to Europe in 1924, he was amazed by the rich blue color of the Mediterranean Sea. This resulted in a paper he wrote on board the ship entitled On the Molecular Scattering of Light in Water and the Color of the Sea. This was the beginning of his love affair with light scattering that would eventually lead to his Nobel-winning discovery.
When light falls on any matter, piece of matter, material, my forehead, for example, is also material. When light is scattered, the color of light changes actually. This change in the color, it's what we call the Raman effect.
Raman and his student Ramanathan and his another student K.S. Krishnan, they separately reported same phenomena. If you pass green light through a liquid, and you will get a very weak yellow light, a very small fraction.
What's happening is the light which is coming in probably has just one wavelength, one component, very pure. But when scattered, it generates many different light beams or different wavelengths. A light, of course, carries energy. When it falls on matter, it makes those atoms and all vibrate. So part of the energy of the light is given to these vibrations, and remaining part is what gets scattered out. This scattered light is a fingerprint of the material. This fingerprint is so unique that you do all material science these days using Raman effect.
You have to measure the wavelength correctly. So he has no money to buy a spectrograph. He wrote to G.D. Birla, give me money to buy a spectrograph, and if you give me the money, I promise I will bring a Nobel Prize in 1 year. So G.D. Birla actually gave him money. Then he became very nervous. Somebody else can also publish. So the first paper he sent to Nature in telegram, and he wrote everything in a nice form of a full paper with spectra, with equations, everything, and he published from Indian Journal of Physics, and he sent the papers by post to several Nobel laureates, Rutherford, Niels Bohr and others, that I believe this is a Nobel Prize winning discovery, you must nominate me for the Nobel Prize. He called a press conference 28th February 1928. It came on the next day that C.V. Raman claimed that he has made a very important discovery and this might get Nobel Prize. And this is why 28th February is called National Science Day.
Now, why did this discovery attract the attention of people like Niels Bohr and Einstein in Europe and the great Sommerfeld, whose students were creating this new revolution? Does matter also behave as a quantum object, or can we continue to describe matter as we had described it from Newton's time? And that is where the importance of Raman's discovery came in. In 1928, Sommerfeld was visiting Japan when he heard about Raman's discovery in February 1928. Let me go to Calcutta and see for myself whether this. So he came to Calcutta. He was convinced that this was a real discovery. And sure enough, as soon as he went back to Europe, all these great guys joined together and proposed Raman for the Nobel Prize.
The Nobel Prize winning telegram came to him on 15th of November 1930. and he went there, received the Nobel Prize, but after receiving the Nobel Prize, he cried on the stage. He said that all other Nobel laureates have their national flag on their chair, but on my chair there was a British Union Jack, and therefore I realized my poor country does not have a flag of our own, so I cannot claim that I have come here as an Indian. And in his official speech, he has dedicated his Nobel Prize to the freedom fighters of India who are spending their golden time of their life in a British jail. This is the spectrograph which Raman used to record the first Raman spectrum, and you can see the photograph of young Raman at the age of 40, and this is a replica of Raman's Nobel Prize. You can see C.V. Raman, 1930, written in the Roman letters.
In a speech to the Royal Society, Lord Rutherford said, "The Raman effect must rank among the best 3 or 4 discoveries in experimental physics." In 1929, he became known as Sir C.V. Raman after being bestowed with a knighthood. Then, in 1934, he was offered directorship of the prestigious Indian Institute of Science in Bangalore. Raman immediately went about revolutionizing the sleepy old establishment. He built new labs, purchased equipment, and tried to bring European scientists who had been persecuted by Hitler to India.
Hitler was becoming more and more popular, and his anti-Semitic views were very clear. All the Jewish physicists left Germany as fast as they could. Many of them were looking for jobs. So what Raman realized, look, if some of them could be persuaded to come to Bangalore, it'll make a huge impact on physics in India. Now the Council of the Indian Institute of Science, which consisted of British industrialists, took a very grim view of this. The council members took the point of view, Schrödinger and Max Planck, they actually used the word, these are second-rate physicists because you are appointing people who have no jobs in Europe, you are giving them a professorship. And so this went all the way up to the Privy Council in London, and then Raman was forced to resign.
He was contractually obliged to teach there and spent the next 12 years teaching, researching, and nurturing young minds. When he had first arrived in Bangalore, the government of Mysore granted him a large piece of land next to the IISc in recognition of his Nobel Prize. In 1934, he established the now famous Indian Academy of Science there, with the vision of making it a world-class body in the mold of the Royal Society. Raman's real dream was to set up his own research institute, and when he retired in 1948, he established the Raman Research Institute at the same place.
He couldn't keep Raman away from students. So even in this institute, in his retirement, you had a bunch of brilliant students for about 10 years.
He designed and built all the buildings and labs himself, planted the trees and gardens, conducted research into crystals, musical acoustics, and optics. The institute was also home for Raman and his wife Lokasundari until the end of their lives. It was his very own haven of knowledge and beauty. This was a wonderful time in his life. In 1960, after 10 years of great work, the institute took a turn away from teaching, and Raman became a hermit-like recluse.
Around 1960, Raman decided not to have any more students because he had disagreement with the government, and he was made a national professor. Nehru was willing to give funds, and Dr. K.S. Krishnan was very influential with Nehru. But Raman rejected all that because they said, look, all you have to do is once a year you have to send some annual report. Raman, in his characteristic fashion, he said, I don't have to send any such thing to you. If you don't want to give me the money, if you want to put fine prints, condition, I don't want your money. A fallout of that was that he could no longer support students.
He built high walls around the grounds, put a large lock on the gate, and had a sign warning people to keep out. But he always had room for children.
There was a guy called Abdul. Abdul will come to Raman and say, some children have come to the gate, sir. So Raman will personally go to the gate, open the gate, bring them in, lock the gate, and spend the day with them, wandering around in the gardens, telling them about the trees and the flowers and the butterflies and so on. I have met some of these people, how that 1 or 2 hours they spent with him, how that passion has rubbed off on them. There are 2 components to Raman's legacy. The Raman effect itself, which was discovered in 1928, continues to be at the forefront of science and technology today in a manner that one never anticipated. That is why chemists and now biologists are very interested in Raman effect as a tool. That is one aspect of it. Intercontinental communication is essentially taking place not through satellite, but through optical fibers. Light is carrying the signals. Raman effect is being used to transmit signals which are coded into light. This is something that if Raman had been alive today, he would have been absolutely thrilled.
Raman once said, "A purposeful life needs an axis or hinge to which it is firmly fixed and yet around which it can freely revolve." As I see it, this axis or hinge has been, in my own case, strongly enough, not the love of science, not even the love of nature, but a certain abstract idealism or belief in the value of the human spirit and the virtue of human endeavour and achievement. On the 21st of November 1970, Sir C.V. Raman passed away and was cremated in his favourite place in the world, the grounds of the Raman Research Institute. Fittingly, Raman's memorial at his favourite institute was a tree.
My dear friends and colleagues, this is a day to celebrate as our institute is putting the name India in the world scenario of science. Professor Saha has realized the immense potential that nuclear science had for the country's development and wanted his Institute of Nuclear Physics to have major research facilities. And I can only say that we are still following his path, and all this proposal was his dream. Meghnad Saha, he is basically a fighter. Right from his childhood, he fought against poverty, he fought against the apathy of the society, initially in the education system, and then also for basic research. He was trying to say that unless India is at the forefront of physics research, as a country we can never become a developed country.
Saha wanted to build a new India. The India of his dreams was to be built on a foundation of basic science and would lead the world once again in intellectual excellence. Saha's equation revolutionized modern astrophysics. He brought nuclear physics to India when the world was just discovering it. His leadership gave us many of India's leading scientific institutions. Born in eastern Bengal in 1893, Saha clawed his way up through sheer willpower and intelligence. He loved mathematics and history.
He was a very favorite student of all the teachers because he excelled on almost all subjects. Mathematics was his favorite subject, and next came history.
He loved stories about Maratha and Rajput kings and saw himself as a new kind of warrior for India's future. He studied at Dhaka College on a scholarship and then made his way to Presidency College in 1910. At college, he got involved with the freedom movement and came into contact with nationalists like Subhash Chandra Bose and Rajendra Prasad. Saha and Bose joined Mukherjee's new college as lecturers in 1916. Between 1917 and 1919, Saha wrote a series of papers on quantum physics and thermodynamics that were published in Philmag and other leading publications in both Britain and India. This got him noticed. Saha married Radha Rani in 1918, and together they had a happy life. She was known to balance his ambition and willpower with her kindness and hospitality. In 1919, Saha won the Premchand Roychand Scholarship to go to Europe on study leave for 2 years. He headed for Alfred Fowler's famous laboratory in London, and the following year he went to work in Berlin with Walter Nernst. By 1919, he had begun to develop the theory that would make him famous.
Astronomers wanted to know, what is the sun made of? The early ideas about the sun and the stars due to Eddington, a 19th century physicist, said, look, the earth is made up of heavy elements. Look around us. So sun can't be very different. Sun must also be made up of heavy elements like iron and copper or whatever it is. But we know the sun is mostly made up of hydrogen. How did people come to this conclusion?
What Saha did was that look in the laboratory, you see that if you heat up something, it glows, it changes color, and so what immediately it came to his mind that if it can happen in the laboratory, it can also happen in that star, it can happen to that star, it can happen to the whole world, universe. The idea is that if you excite an atom, if you excite, then what happens, the electrons are excited to another level, and when they come back, they emit a radiation. But from there to think that a star's temperature can be calculated by measurement of the line emission, this is just an extraordinary extrapolation.
So he gave this equation which took into account the temperature and pressure inside a stellar body and how that would lead to ionization. In fact, he was the first person to apply quantum theory to stellar objects.
He wrote a paper entitled Ionization in the Solar Chromosphere, and it was published in Filmmag in 1920, while he was still in Europe.
There was a young lady in Harvard, Henrietta Leavitt was her name, and she said, let me use Saha's new equations and try to estimate how much hydrogen there is in the sun. Nobody had done that before. She said that nobody else had said that the sun is made up of mostly hydrogen. Her thesis examiner was the high priest of astrophysics in America, Henry Norris Russell, professor of astrophysics in Princeton University. And then he actually sat down with Saha's paper and said, let me redo what she has done. The great Henry Norris Russell, instead of hushing it up, openly came and said, I was wrong, we are all wrong, she is right. So the sun and the stars are made of hydrogen predominantly. And therefore you can see, although Saha's equations were, in a sense, a small extension of the existing theory, quantum theory of atoms, which was emerging due to Bohr and his colleagues and so on. It was not a huge step like Bose took. It was not a huge experimental step like Raman did. But it led to a tremendously profound application in astronomy where precisely this sort of tool was needed to interpret the spectrum of the stars.
He returned to Calcutta in 1921, and his new reputation as an international scientist earned him the Cairo professorship. But by 1923, his requests for grants and funding for new labs and research facilities were rejected, and he decided to leave Calcutta and head for the United Provinces. At Allahabad University, he built a new physics department. In 1927, Saha was made a Fellow of the Royal Society. In 1930, Saha was nominated for a Nobel Prize for his work on stellar ionization. Saha finally took on the role of institution builder that year with the founding of the United Provinces Academy of Sciences. He also joined the IACS in Calcutta, where Raman was still the honorary secretary. Saha returned to Calcutta and his alma mater in 1938 to become the Pilot Professor and head up the physics department.
Meghnad Saha came back from Allahabad University as a Palit professor. At that time, Netaji Subhash Bose became President of Congress. He proposed that India should have a planning commission. So this was set up in 1939 with Jawaharlal Nehru as the chairman. Meghnad Saha was a member, and Meghnad Saha started planning about many things, like atomic energy should be introduced,
He started teaching nuclear physics in 1940, and by 1947 launched the Institute of Nuclear Physics at Calcutta University. After his death, this became known as the Saha Institute of Nuclear Physics. In 1944, he became secretary of IACS, and by 1946 was president and running the whole place. His dream was to make IACS the national academy he had dreamt of.
Up to that point, IACS was a club, only one faculty, people can freely come and go, but there is no faculty position, no director, no professor position. He said this cannot be an institute. He said he wanted some 20-30 faculty positions, a new campus, much bigger one, lot of money and assured government grant.
Saha also realized that the only way he could get change accelerated was by joining politics, and in 1952 he became an independent member of the Indian Parliament. Ironically, his end was as dramatic as his life, as he died of a massive heart attack on the stairs of the planning commission he had helped set up in New Delhi. It was a fitting end, like a Rajasthani warrior of old.
He taught us how to keep your head high and keep fighting, so that the fundamental research, basic research is done in the country in a good way.
And what a life he had. Every student of astrophysics studies the Saha equation in their first year. Today, both the Indian Association for the Cultivation of Science and the Saha Nuclear Institute are two of India's finest research centres, working on international projects as diverse as the Higgs boson, nanomaterial sciences, advanced space research and communications. On his passing, D.S. Kothari said of Saha, "The life of Saha was in a sense an integral part of the growth of scientific research and progress in India, and the effect of his views and personality would be felt for a long time to come in almost every aspect of science activity in the country. His dedication to science will long remain an inspiration and an example." What did the quantum Indians give us? Bose gave us the Bose-Einstein statistics and condensates, and all bosons were named after him. Raman gave us the Raman effect and India's first and only Nobel Prize for Science. His genius and leadership helped shape some of India's leading institutions and scientists. Saha not only revolutionized astrophysics, but also built a substantial part of India's science infrastructure in its early days after independence. India seems to have lost its love affair with basic science and research, as technologies and engineering were urgently needed for development and progress. But today, things are turning around as India emerges as a global power. The universities and scientific institutions are once again working together, and Indian scientists are collaborating and publishing all over the world. We are seeing many giant leaps forward in material and nanosciences, astrophysics, space research, cosmology, pharmaceuticals and medicine. So, what can we learn from Bose, Raman and Saha today? Bose said, "Never accept an idea as long as you yourself are not satisfied with its consistency and logical structure on which the concepts are based." Saha said, "Scientists are often accused of living in the ivory tower and not troubling their mind with realities, but science and technology are as important for administration nowadays as law and order. I wanted to be of some use to the country in my own humble way." And Raman was characteristic in his own way.
No, but I think the chief thing is to take some pleasure in your work. Personally, I say that our salvation is in our own hands. If we in this country make up our mind that we go do something, we'll find something to do, and we shall certainly get a place in the stimulus is very needed. See, a stimulus is sometimes they say it is not a spirit of mutual admiration. To a certain extent, criticism, even hostility, provided it is not carried too far, is good for a man.
There is a surplus in man, which makes man different from all other animals. Man is the first animal who is known to have created things. Man is the first animal who have realized that there is a whole wide world around us. And man wants to know. So God knows what is coming next. It's just going to widen our horizons and widen our horizons forever.